Good morning, everyone. Today I am going to explain types of digital to analog converters, need for analog to digital conversion, and digital to analog conversion. Before going to start today's topic, we are already completed about analog signals and digital signals, and also completed differences between analog signals and digital signals. Along with these topics, we are already completed instrumentation amplifier and instrumentation amplifier using 3 op amps. Also differences between instrumentational amplifier and operational amplifier. First, analog signal. Analog means it is a continuous. The amplitude of signal will be continuously vary with time. So the amplitude will be continuously changing with respect to time. Analog signals is the basic type of communication system, but the main disadvantage in analog signals is noise. The analog signals, the output of analog signals is more noise. So noise limitation purpose, we can control the amplitude limitations. Whenever we are just limit the amplitude limitations, we can get distorted output across the output section. The distorted output is nothing but it contains the noisy output, or the signal will be imperfect. So the overcoming analog signal problems, then we go for digital signal. The digital signal is, it will be used for reducing the problems in analog signal. The main problem reduces in digital signal is noise. In digital signal, less noise and accuracy is more. Digital contains only fixed bandwidth, fixed width and fixed amplitude. That is nothing but digital, it have only discrete levels, that is nothing but 190. The logic 1 it indicating the high value and logic 0 indicating the low value. So the output of digital signals, it will be contains only one sign zeros, means binary high or low. Otherwise in analog signals, it will be changed continuously with time. Next, the cost wise analog signals will be less cost compared with digital signal. And analog signals, one of advantages, it occupies less bandwidth, whereas digital signal occupies more bandwidth. But the output of digital signals with high accuracy and low noise compared with analog signals. So that's why we choose to compare to analog, digital is more popular. So these are the topics we are covered in previous classes. Also instrumentation amplifier. Instrumentation amplifier is nothing but it will be designed with 3 operational amplifiers. The 2 operational amplifiers, it works as buffer. So buffer is nothing but input impedance purpose. Next, and also measurement and test equipment. Buffer type of amplifier is nothing but it will matches the input impedance, and it increases the input impedance. And next, measurement and test equipment purpose. Next, differences between op amp and instrumentation amplifier also completed. Instrumentational amplifier main application is, it will be used in biomedical applications. Next, then after next topics in our subject is A to D and D to A conversions. A to D stands for analog to digital, and D to A stands for digital to analog conversion. Why we are converting analog to digital or digital to analog? Next, some of the definitions will be related to digital to analog converter. And the last topic in our class is types of digital to analog converter. First, today's topic is need for analog to digital and digital to analog conversion. Converting one term into another term, either analog to digital or digital to analog. Conversion is nothing but exchanging analog values to digital values, or digital to exchanging. So most of the signals will be available in analog form, nature in analog form only. So the nature in analog form, general signals are voice, music, sound, temperature, pressure, velocity. These are available in analog form only. So the analog signals are greatly affected by the noise, or the main disadvantage of analog signal is the noise only. So the analog signals are greatly affected by noise and can be reduced by digital system. The noise can be reduced by digital system. The main advantage of digital processing of signal is that effect of noise on the signal can be greatly reduced, whereas analog signal contain more noise and digital signal contain less noise. The noise will be the noise reduction in digital signals. Therefore the analog signals will be first converted into digital form before they processed and digitally by using analog to digital converter. So the need of analog to digital conversion is by reducing the main cause of conversion is by reducing the noise purpose. So first the analog signals are first converted into digital form before they processed in digitally. So it will be converted in digital form after they processed in digitally. So by using of A to D converter we can convert. Next, again the digital signals are processed signals and it will be converted into analog form by using digital to analog converter. The processed signal, first the signals are converted into digitally and then processed, and processed signals are again converted into original form. The original form is nothing but here the original form is analog form. The processed signal is converted into analog form by using digital to analog converter. So first analog to digital converter is used for conversion of analog signals into digitally before going to start processed then digitally. Next, the processed digital signals are used for conversion from digital to analog converter. So the output itself analog value only. Example, music. So music is an analog signal. First it is digitally recorded, later it converted into analog form for playback purpose. First music is analog signal, so it will be converted analog to digital by using of A to D converter, analog to digital converter. So that is nothing but analog music is recorded in digitally, then the digitally and processed. After processing again it will be come back into original form means, and later it will be converted into analog signal from playback purpose. To accomplish this require analog to accomplish this type of it require analog to digital and digital to analog converters. So processing of converting analog signals in the form of digital, again it converts into analog signal. Processing of means, in example, first processing of converting signal is nothing but music signal. The music signal is first itself converted into digitally, that is nothing but it will be recorded in digitally, again it will be converted into analog form, that is nothing but the digital signal later converted into playback signal. The analog playback signal, analog form for playbacking purpose. Playbacking is a form of analog and music also in the form of analog only, but the music signal is recorded digitally and converted into analog playback form. So this is the analog to digital conversion form. First the signal is in analog signal input. So we are taking the analog signal input. Next, by using of A to D converter, the analog signal will be converted into digital signal. Next, the output of A to D converter is the digital signal, that is nothing but digital signal processor. Next, the digital signal will be again converted into analog form. The analog digital signals are again converted into analog form by using of digital to analog converter, and the last one is the output is nothing but analog signal output. So here we are applying the analog input and we are getting the analog output only, but in middle of session our communication purpose, first it will be converted into A to D converter, means analog signals will be converted into digitally. The analog signal is an example of music signal. So here we are using A to D converter, so analog signal will be converted into digitally. The music signal is recorded digitally in A to D converter, and the digital signals are deconverted into digital to analog, deconverted by using of digital to analog converter. And the last one is the digital to analog converter output, means the analog signals we are getting output signal. The analog signal is nothing but playbacking signal. First analog input, analog to digital conversion, next digital output. The digital output will be again converted into digital to analog converter and it will be used for, and then after analog signal, digital to analog converter output is the analog signal output only, digital to analog converter. So it will be converted in the form of analog only. So the why we are conversion from A to D to A means the reducing of noise. analog to digital, digital to analog conversion is nothing but noise reducing purpose. Noise reduction is the main important in communication. So we are getting the perfect signal or accurate signal. So first analog signals are applied to analog to digital converter, that is nothing but A to D converter. So it is used to convert analog signals into digital. Later the digital signals are fed to digital signal processor. Next, digital signal processing system uses a computer or digital processor to process the signal. So DSP stands for digital signal processor, means it uses a computer or digital processor or processing signal. Digital processor or process to signal. Next, after processing, the signals are directly converted into analog. A device called digital to analog converter. First analog to digital converter, later digital signal is fed to digital signal processor. The digital signal processor, it requires computer. The computer is our digital processor, computer or digital processor to process the signal. Next, again it will be fed to digital to analog converter. So this is the analog to digital, and next one is the digital to analog converter. So here VA is nothing but analog input. So the analog input will be converted into digital output. By using of A to D converter, we can convert VA, analog voltage, will be converted into digital voltage. So this is what parts of your iPhone operation, either analog or digital, how it can communicate. Next, digital to analog. The digital input, first one is the analog input, then we are getting the digital output, and digital output will be fed to input of digital to analog converter. The digital output as work as input of digital to analog converter, that is nothing but input will be digital value, and after we are getting the analog voltage only. First analog voltage converted by using of A to D converter through digital value, and the digital value will be given to D to A converter input, and we are getting the again analog output. Same like this, analog signal, next digital analog signal, conversion A to D converter, next again D to A converter, processed signal, and it will be given to digital to analog converter, and then afterwards we are getting the analog to signal output. Next, analog to digital conversion. So an ADC, it converts analog signals into digital coded signals. ADC stands for analog to digital converter. So the analog to digital converter converts analog signals into digital signals. There are types of analog to digital converters like successive approximation. These are the different methods to convert analog information into digital information. That is nothing but analog signals to digital signals. One is a successive approximation, counter type. Next, integrating or dual slope. Last one is a parallel or flash method. These are the some methods by using conversion from analog to digital signals. So here we are given the analog input by using of A to D converter. Here we are giving the analog input by using of A to D converter or ADC. A to D converter is also called ADC, analog to digital converter, and then we are getting the digital output, analog input, A to D, and digital output. So it is also used by using analog input followed by sample and hold circuit, quantizer, encoder, and then we are getting the digital output. The main inputs are sample, hold circuit, quantizer, and encoder. This is also A to D. So here we are giving the analog input. So analog input will be converted by using of analog to digital converter. Next, these are the digital outputs. Digital outputs is nothing but it contains only binary values, that is nothing but B0, B1, B2. So the digital output is nothing but just like ramp or staircase output. The staircase output is nothing but it contains only 1 and 0, binary 1 and binary 0. So analog input is nothing but it is in the continuous with time. So the analog input will be converted to A to D converter. Analog input is given to A to D converter, then it will be converted into digital. The output of A to D converter is the digital value. B0 LSB, it stands for least significant bit, and MSB stands for most significant bit. So it have least and most significant bits. Next, digital to analog conversion. Same reverse operation of ADC. First analog to digital means we are giving analog input, then we are getting the digital output. Here digital to analog converter means first we are giving the digital input, then after we are getting the analog output. That is nothing but a digital to analog converter, also known as D2A converter or DAC. D2A converter or DAC, digital to analog converter. A digital to analog converter, it converts a digital signal into analog signal in the form of voltage or current. The digital signal is nothing but it will be the binary 1s and 0. The discrete inputs will be given to D2A converter. Then we are getting the analog output. The output of analog is in the form of voltage or current. So there are also two methods. Digital to analog conversion also two methods. One is used for binary weighted resistor method, conversion from digital value into analog value by using a binary weighted resistor, and second one is the R2 2R ladder network. So for analog to digital conversion we have four methods: successive approximation, counter, integrating type, or it also known as dual. Next, parallel method or flash method. The digital to analog converter is nothing but here we are applying the digital input. The digital input will be decoded and the decoded output given to sample and hold circuit, and the output of sample and hold circuit is the analog output. Analog output is nothing but it is in the form of voltage and current. So here we are using decoder. Digital to analog converter uses decoder, whereas analog to digital converter it uses encoder. So here we are using encoder. Here we are using encoder, and sample and hold circuit is a analog input, output is given, analog input is given to sample and hold circuit. The output of sample and hold circuit is given to quantizer. So analog input is applied through sample and hold circuit, and last one is the digital output where we can get from encoder section. The reverse operation is in digital to analog converter we are giving the digital input and we are getting analog output. That is nothing but digital input is given to decoder section, whereas we are getting digital output is encoder section. Here the digital input is given to decoder section, then afterwards decoder to given sample and hold circuit, whereas in ADC the analog input is given to sample and hold circuit. In digital to analog converter we can get analog output from sample and hold circuit, whereas input is given in sample and hold circuit in ADC conversion. In DAC we get analog output from sample and hold circuit. So this is the block diagram of digital to analog converter. Digital to analog converter nothing but a digital signal is converted into analog form in the form of voltage or current by using of two methods. The main two methods are binary weighted method, and second one is the R2 2R ladder method. So this is all about A to D converters and D to A converters, or it is also known as analog to digital converter and digital to analog converter, or it is also known as ADC and DAC. ADC is analog to digital conversion, DAC is nothing but digital to analog conversion. There are some definitions related to digital to analog converter. Digital to analog converter means we are giving the digital input and we are getting the analog output. Digital input is applied. Same, this is digital input is applied, and then after we can get the analog output. Digital input and analog output. So this is the D to A converter definitions. D to A means digital input is given, analog output we take it. So resolution, first definition, digital to analog converter, first definition is resolution. The resolution of digital to analog converter is defined as the reciprocal of number of discrete steps in the DAC output. Reciprocal of number of discrete steps. This is the steps, discrete steps. This is the discrete steps in DAC output. So the resolution of is defined as, resolution is nothing but digital to analog converter is defined as it is the reciprocal of number of discrete steps in the DAC output. This is the DAC output. DAC output. DAC output. And next one is the reciprocal of number of discrete steps in the DAC output is nothing but it is defined as resolution. Our resolution is equals to 1 by total number of steps. If it requires n number of steps, that our resolution formula is 1 by 2 power n minus 1. Resolution is equals to 1 by 2 power n minus 1. Our percentage resolution is equals to 1 by 2 power n minus 1 into 100. The percentage resolution is equals to 100 value. So resolution of DA to A converter is defined as it is the reciprocal of number of discrete steps in the DAC output. That is nothing but digital to analog converter output. Number of discrete steps is nothing but 1 by total number of steps is nothing but it can written as 1 by 2 power n minus 1. Next, monotonicity. Mono means single. So monotonicity is nothing but it is defined as the ability of digital to analog converter is the analog output moves on the direction through digital input moves, or it is defined as the ability of digital to analog converter. The analog output moves in the direction of digital input. Or non-monotonic means if the output decreases when the binary input is incremented. That is nothing but non-monotonic. If the output is decreases when the binary input value is incremented. The term derives from the monotonic is the mathematical functions also known as non-decreasing functions, in which the value will be dependent variable never decreases the value with independent variable increases. Next, the main definition of monotonicity is nothing but first definition is it is the ability of DAC analog output is moves on the direction with digital input, or it is also known as monotonicity is the property of certain types of digital to analog converter circuits. In monotonic DAC, the analog output always increases, remains constant with digital input increases. The analog output always constant or remains, always increases or constant. In the digital, constant as the digital input. Same as the analog output moves in the direction of digital input. Same the version will be written as the analog output always increases or remain constant means the analog output which follows the digital input. The analog output digital. Why? Because it is a digital to analog converter. So that's why the analog digital is the input, analog is the output. Though the analog output which follows the digital input signal. Same here also the analog output always increases or remains constant in the digital input is increases. The analog output never decreases during the input sequences. Next, if the analog output decreases at any point during the input sequences, a DAC is said to be non-monotonic. So the analog output will be either constant or increases. If at all the analog output will be decreased, the signal, the circuit is non-monotonic. If the analog output is decreases at any point of the input sequence is called non-monotonic. Monotonic means the analog output which follows the digital input, and next analog output increases by increasing the digital input. Analog output constant or increases by using of digital input, whereas when analog output will be decreased, the circuit will be non-monotonic. The analog output will be constant or it will be increased, the circuit is called monotonic. If the analog output is decreased, the circuit is called non-monotonic. Next, accuracy. Accuracy means accuracy is perfect. General accuracy meaning is perfection or without noise, noiseless. So the accuracy of digital to analog converter is the comparison of actual output of digital to analog converter with expected output. Actual output will be compared with expected output. So both are equal. Actual output and expected output are equal. The circuit will be more accurate. Otherwise less accurate, or the circuit contains noisy. The digital to analog converter contains noisy output. So the accuracy of digital to analog converter is the comparison of actual output of digital to analog converter with expected output. Or accuracy is the maximum deviation between the actual converter output and the ideal converter output. Maximum deviation between actual converter output and ideal converter output accuracy. Next, deviation means changes. Maximum deviation between actual converter output and ideal converter. Ideal means we can get 100% result. Actual means practical. Next, relative accuracy is the maximum deviation after gain and offset errors have been removed. So relative accuracy is nothing but maximum deviation after gain and offset errors are removed. So accuracy is nothing but the manufacturer of digital to analog converter has several ways to define accuracy. Two of them often referred as linearity error and full scale error. So accuracy means actual output will be different with expected output, or the ideal output will be changed with practical output. So manufacturer will be decide some digital to analog converters have several defined accuracy methods. Digital to analog converter has several ways of accuracy. The main two terms are linearity error. If at all we are getting noisy output, the noisy is in the terms of either linearity or full scale error. Full scale error is nothing but the maximum deviation of digital to ideal digital to analog converter output value. Next, for example, a 4-bit DAC has plus or minus 0.01% of full scale accuracy. Next, the scale value is 15, so it is will be 0.01 into 15 per 0.01% into 15 is nothing but the accuracy will be changed either plus or minus 1.5 millivolts. Next, this means the DAC output will be different from ideal value 1.5 millivolts. So actual output is 15 volts. So I expect ideal output is 15 volts, and but the practical output we are getting plus or minus 1.5 deviation with 15 volts. Why? Because it contains the linearity error or full scale error. The full scale error is nothing but maximum deviation of digital to analog converter output. So how we can get the maximum deviation is nothing but, so for a 4-bit DAC, the full scale error is approximately plus or minus 0.1%. The full scale value is, the full scale is nothing but the output value digital to analog converted output is 15 volts. So the 15 volts we are not getting perfectly 15 volts. So 15 volts either will be incremented or decremented. Why? Because we contain the full scale accuracy error, full scale error. So that's why 0.01% will be multiplied with 15. That is nothing but it changes in plus or minus 1.5 millivolts. So the output of the signal will be either plus or minus 1.5 millivolts will be changed from 15 volts. Next, settling time. A settling time, it represents the time taken for the output to settle within a specified band. That is nothing but specified band of plus or minus 1/2 of LSB of its final value after changing the digital input. So it represents time it takes the output to settle. What is the output value? Digital to analog converter. So the output value settle within a specified band of plus or minus 1/2 of LSB. LSB stands for least significant bit of its final value. Specified with a least significant bit of its final value after change in the digital input. Or it is also known as, it is a time for the digital to analog converter output to settle with a plus or minus 1/2 of step size of its final value. So it will settle the plus or minus 1/2 of step size value, or it is also defined as, it is the defined as the time until output voltage reached and don't leaves again defined voltage in tolerance band. So the settling time, it should be as small as possible. So this is the error band, settling time with respect to output. This is error band. Next, dead time, slow time, recovery time, and linear settling. Full scale settling time. Settling time is nothing but the digital to analog converter to settle with a plus or minus 1/2 of step size, or it is also known as the output to settle with a specified band of plus or minus 1/2 of LSB its final value after changing the digital input. When we are changing the digital input, the output contains the changes in plus or minus 1/2 of LSB. Choosing DAC, digital to analog converter settling time. Ideally, digital to analog converter would be a instantaneously change its output value when the digital input would be changed. So digital to analog converter instantaneously change output value. Output value is nothing but the output is in the terms of analog only. So the analog value will be changed when the digital input would be changes. However, in real digital to analog converter, it takes the time for digital to analog converter to reach the actual expected output, expected output value. So this is the plus or minus 1/2 bit. Next, that is nothing but plus 1/2. Next, minus 1/2 suffix value, and middle value is nothing but expected bit. So DAC will be nothing but the output will be changed when changing DAC of input. So in DAC it takes time for, in practical cases or in real world, the DAC takes time for to reach the actual or expected value. There are some digital to analog converters. The types of digital to analog converters mainly binary weighted resistor type DAC, and second one is the R2 2R ladder DAC. Binary weighted. So weight, binary is nothing but it will be in the values of digitals only, ones and zeros. Next, by using of ones and zero weights, we can change the resistor type into digital to analog converter, binary weighted resistor digital to analog converter, or the circuit using R2 to R ladder type. So these are the main types of digital to analog converters. So here first we are giving the digital input signal. The digital input signal is nothing but it contains only ones and zeros only. So why? Because it is a type of digital to analog converter. So the digital to analog converter, digital signals are the input signals. We are taking a device digital to analog converter. The output of digital to analog converter is in the form of analog signal. So digital to analog converter. So here we are using digital to analog converter as either binary weighted DAC or R2 to R ladder DAC. Here the DAC is nothing but binary weighted type or R2 to R ladder DAC. Next, the types of digital to analog converter. There are two types of digital to analog converter. That is nothing but weighted resistor, and another one is the R2 to R ladder network. Here we are giving the n-bit digital data. N-bit digital data is nothing but n number of bits is given in a digital form. So the n number of bits will be converted into analog data. So this is the digital to analog converter. So today we are completed about these are the already today's class. So we are completed analog to digital conversion, definitions, and digital to analog converters. The analog to digital conversion or digital to analog conversion main aim is nothing but perfect output purpose. Perfect output is nothing but reducing the noise. So most of the signals are in analog form. The analog signal main disadvantage, analog is a basic, okay, but the main disadvantage is it contains noise. So the reduction of noise purpose, then we choose the digital signals. The digital signals are cost more compared to analog signals, but the main advantage in digital signal is accuracy and noise. It takes less time to complete the signal. So digital signals is nothing but it is in a form of discrete, means ones and zeros only. Next, so analog signals are greatly affected by noise reduction purpose, we can go for digital signals. So the digital signals are first, the analog signals are first converted into digital form, so before going to processed. So and next, after processed signal, it will be again converted into digital to analog converter. So the analog signals are first converted into digital form before they processed it digitally. So first it will be converted into digitally, then processing is starts. After completion of digital process, again it will be converted into digital to analog converter. So conversion purpose, we are using A to D and D to A circuits. A to D is nothing but analog to digital. So analog signals will be converted into digital. The analog input is nothing but it is in the time of voltage, it is in the type of voltage or current. It will be changed into discrete, means binary ones and zeros. After conversion, the binary ones and zeros is the input values, and the binary ones and zeros will be converted into analog output like voltage or current. So analog signals every time first we are applied into A to D converter. The A to D converter name is also known as analog to digital converter, ADC. A to D, or it is also known as ADC. So first it will be processed into digital, later the digital signals are fed to digital signal processor. Generally we are using as in digital signal processors as computers or processors, digital processors. The computers or digital processors are used for processing the signals in digitally. Computers or processors are used for processing the signals. Next, then afterwards the digital signals are again it will be converted into analog. by using of digital to analog converter means it will be come back into its original state. First it will be is an analog state, next it will be converted by using analog to digital converter means the output will be out digital section, next it will be processed digitally after digital process, and then it will be applied to digital to analog converter. Next then afterwards the digital to analog converter is the output of analog value only, the analog output. This is the same block diagram, analog digital, next to digital to analog. So analog to digital converters, first conversion of analog signals into digitally. The main types of analog to digital converters are, there are main four methods is successive approximation type, counter type, flash type, or it is also known as flash type ADC, is also known as parallel type ADC, and the last one is the integrating dual slope ADC, integrating or dual slope ADC, analog to digital converter. Successive approximation, counter, integrating or dual slope, and the last one is parallel or flash method. So analog to digital conversion method, the analog input is given and we can get the digital output. So the analog input is given to sample and hold circuit, then quantizer, and last one is the encoding. Next then we can get the digital output. This is the internal section of A to D conversion. So A to D conversion internal section, it takes sample, hold, circuit, quantizer and encoder methods. Next the three methods is sample, hold, encoder, quantizer, and next we are giving analog input and find out in the digital output. The digital output is nothing but it is the values in binaries B0, B1, B2. So binary values, it starts from least significant bit to most significant bit. Most significant is the highest priority. So binary values means it contains only zeros and ones. Next digital to analog converter is nothing but we are giving the digital input and find out in the analog output. The digital input is in the form of only binary inputs or discrete inputs like ones and zeros. The ones and zeros will be given and the output of D to A converter is in the type of voltage or current. So digital to analog converter, the main parts it includes in internally is decoder, whereas in analog to digital converter it uses encoder. Here we are using decoder and sample and hold circuit. There also sample, hold circuit, encoder, quantization are the three methods for A to D conversion. For D to A conversion, decoder and sample and hold circuits are used. D to A conversion means digital input is applied and we can get the analog output. There are some definitions related to digital to analog converter means digital input is given, analog output will be taken. So the definitions is related to resolution. Resolution is nothing but reciprocal of total number of discrete steps in the DAC. Discrete steps is nothing but binary inputs. Digital to analog converter inputs. Total number of reciprocal of total number of discrete steps applied in digital to analog converter, that is nothing but 1 by total number of bits, that is nothing but 1 by 2 power n minus 1. Percentage resolution is nothing but 1 by 2 power n minus 1 into 100. Monotonicity is nothing but mono, single. So monotonicity is nothing but digital to analog converter is nothing but the output value is in the type of analog only. So the analog output which follows digital input is called monotonicity or monotonic signal, the ability of DAC analog output which moves in the direction of digital input. So the analog output follows the digital input. The analog output which will be constant or it will be increased by using of digital to analog converter or changes in the digital input. But if the analog output value will be decreased, it will be constant or same whenever changes in a digital input, it called monotonicity. So that is nothing but the analog output which follows or which moves in the direction of digital input, whereas analog output value will be decreased. The output of analog value will be decreased or the output will be decreases when binary input is incremented. So binary inputs incremented, the output value will be decreases. The case arises only in non-monotonic signals. The non-monotonic means the output value will be decreases where we are increasing the binary inputs. Normal monotonic means the output value, the output is nothing but analog output which follows or which moves in the direction of digital inputs. The output will be decreased, it is called output is decreases when we are increasing digital signals also, the output is decreases, it is called non-monotonic signals. So the monotonic is a mathematical function and it also known as non-decreasing functions. Decreasing functions is called non-monotonic. Non-decreasing functions is called monotonic. Accuracy is nothing but it will be the relation between original value with expected value. The original value and expected value are equal, so it will be get more accurate signal or 100% accurate signal. So the ideal value and the practical value means practical output value will be difference. So the deviation will be arises. Mainly the accuracy will be depends on two types of errors. One is the linearity error, one is the full scale error. So accuracy depends on linearity or full scale. So accuracy is the maximum deviation between the actual converter output with the ideal converter output. Ideal converter output is nothing but normal. Actual converter output is the practical cases. Settling time. To settle the output bit with changes in digital input. Settle the output bit changes in specified band of plus or minus 1 by 2 of least significant value of its final bit after change in digital input. Next, there are some types of digital to analog converters. So digital to analog converters means we are giving the digital input and find out in the analog output. So digital to analog conversion, digital input to analog conversion purpose, the two methods are popularly known. One is the R2-2R ladder network, second one is the binary weighted resistor. By using of these two methods we can change the digital input into analog output. The digital signals will be moved into analog type of output. Digital signals is nothing but binary signals, it can change into analog signals. In next classes we can discuss about binary weighted type, how it can change the values from digital to analog by using of binary weighted resistor, the circuit diagram. Next exam, binary weighted resistor applications, where we can use, how it can works. Next R2-2R ladder network, where we can use, how it can works, and differences between R2-2R ladder network and binary weighted resistor. Both are used for digital to analog conversion process only, but what are the differences between the both two types, binary weighted and R2-2R ladder, and which is best for conversion type of? Best is nothing but easiest to process, simple circuit, which is the best circuit. So later we can discuss about binary weighted and R2-2R ladder DSC. So this is up to about today's class. Today we are completed about conversions, definitions of analog to digital conversion and digital to analog conversion. Next, some definitions like resolution, monotonicity, settling time. Settling time. Next, accuracy related definitions. Next, types related to binary weighted. Just type, what are the types of binary weighted and what are the types of digital to analog converter is binary weighted and R2-2R. Whereas analog to digital converter types is successive approximation, flash type, next integrating type and counter type. It is also next classes we can discuss about binary weighted resistor in R2-2R ladder network, how it can work in circuit diagrams. And after ADC, types of conversion also we can discuss in next classes. Types of ADC, successive approximation, counter type, and differences between the successive approximation, counter types, also applications, binary weighted resistor and R2-2R applications. So later we can discuss about these topics. Okay, thank you all.